excited to be joined by Josh King today. Josh is a research scientist at Environment and Climate Change Canada who studies changes in snow in the Canadian Arctic and around the world. So using planes, satellites, even Twitter, he's developing new methods to measure how much water is stored in snow to better understand its importance. So Josh gets to travel north on many expeditions. The last time we talked to him, he had just returned from a field campaign in the Northwest Territories. So we're excited, Josh, to be hanging out with you today to learn a little bit more about what you've been up to since we chatted last. And of course, we'll turn things over to our classrooms and let them fire away with some questions when the time comes.
Great. Thanks for the introduction, Joe. Sorry about having some problems with the slides this morning, but I'm glad that you'll be able to show them for me. So I'm really excited to talk to everybody today because, as Joe said, I've recently come back from a field campaign, and I've actually come back from another one since. So I'm going to talk a bit about what we did there and the importance of snow. And as I'm talking and we're looking at pictures, I want you to think up some questions about snow or about the Arctic. You can even tell me something interesting that you already know about snow if you like. We'll just start talking about it that way. So I'm ready if you are, Joe.
All right, perfect. So just a reminder, classrooms, this is the time to come up to the front and click on my screen so it's highlighted in white, and I'm going to do it on my own screen as well, so it's locked that way for our YouTube viewers, and the screen share should start now. All right, Josh, just let me know how it's looking and I'll go full screen.
Great, I can see the whole slide. Perfect. All right, good morning, everybody. So today we're going to talk about snow and ice. I'm really excited to talk to you about this because we've recently released at Environment and Climate Change Canada a report on Canada's changing north. And as part of that, snow is a big part of climate change. So I'd like to talk about that and also a little about the work that I do in the Arctic that's related to snow and ice. Next slide, please. So as Joe said, my name's Josh, and I'm a climate scientist at Environment and Climate Change Canada, where I study the Arctic and snow. But when people ask me what I study, I like to tell them about something called the cryosphere. So this might be a new word to some of you. So let's break it down and take a look at what it means so that we can understand it. And if you can press next, Joe. So the first part of that word here, where we see cryosphere, means cold. So I want you to think cold when you think cryosphere. And the second part, if you press again, is the word sphere. So that's probably a word that you've already heard. And I want you to think about something round, like the globe. More specifically, in this case, we're talking about the places on it. So when we combine those two words, the word cryosphere, what does it mean? Well, I study cold places around the world. If you can press again, Joe. So the places I work are often below 0 Celsius or 32 Fahrenheit, so very cold. And we can find snow and ice in all of those places for up to about 9 months of the year. Next slide, please. So this slide here shows a diagram of the different places that I work. So I'm talking to you today from Toronto, Ontario, Canada, down in the sort of bottom right here of Canada. The places that I work have interesting names like Churchill, Inuvik, Alert, and Eureka. So these are all over the Canadian Arctic. The thing that's most common to these places is that they're all really cold in winter. So the map in the background here shows you what the temperatures are like between December and February in different places of Canada. So you can see in the very far north, where it's very dark blue color, the temperatures are very cold, below -20 Celsius. Now, just because some of the map shows that it's really cold where I work, snow is important to a lot of places in Canada. So for example, in the southwest of British Columbia, sort of on the bottom left part of Canada, where the winters are more mild, snow in the mountains is important for things like, say, skiing or for water. We'll talk a bit about that more later. Next slide, please. They might be wondering, what do these places look like in winter? So here's a picture of me working in a place called Eureka, Nunavut, out on sea ice in the middle of winter. It's really cold. I'm standing out on sea ice. And just about everywhere you can look around me, you see snow and ice. In the Arctic, up to about 80% of our annual precipitation, so water that comes from the sky, falls in the form of snow. So in areas like this, it's a really important part of the environment to study if there's snow quite a bit of the time. The air is also very cold and the wind's really strong. And so it can make it really hard for us to work. And in the picture here, you can see some of that snow blowing along the ground as I'm working on this weather station. Next slide, please. But the weather in the Arctic isn't always bad. So in this picture, you can see an airplane sort of near the top, and we've landed it on the ice near the North Pole. So we've headed quite a bit further than where I was in the last picture, but the weather's nice and sunny and the winds are calm in this photo. So even though we do get some bad weather and it's tough to work, there's also times that it's really fun. I wouldn't want to wear a t-shirt necessarily in this picture, but I really enjoyed making the measurements here. So you can see me, I'm the person that's sort of digging in the snow and taking some measurements behind the plane. Next slide, please. Other times of the year can be really challenging to work because the sun just doesn't come up. We call this polar darkness. In the picture here, you can see me working in the Northwest Territories this past January. And at that time of the year, we experienced something called polar darkness. So at this time of the year, because of the way the Earth's orbit occurs, we don't see the sun come up above the horizon for a couple months. It's completely dark outside, but it's not completely dark outside all the time. You can see some of the sun sort of peeking above the horizon here, but it's dark enough that we often have to use flashlights. So that little bright spot that you sort of see on my head there, that's a flashlight that's helping me to work. Next slide. Okay, so scientists like me have been studying snow using satellites in space for over 70 years now. It's an important part. It's important work for us to do because snow covers about 40% of the Earth. So even though you might not see it right now where you live, or you might not see it at all, there's still plenty around us in the world. So this animation that you're seeing on the right is showing you how the snow cover changes in North America from the summer to the winter. So in the winter, it comes all the way back to just the Arctic, sort of the middle of that animation. And then in the winter, it expands all the way out, covering all different parts of North America. Now, looking at snow cover over really long periods, we've noticed two things. If you could press next, Joe, for me. Those two things are, we're noticing that in the spring, our snow is starting to melt earlier. So the timing of when the snow starts to come back to just the Arctic is happening much earlier in the year. And also in the winter, we're seeing that snow is not moving as far south. So in general, the Earth is being covered by less and less snow each year. Now, scientists agree that this isn't a good thing and that humans are causing this as part of climate change. So let's talk a bit about why this is important. So if you've ever looked outside and you saw snow or you've seen snow on television, you might have wondered, why is it so bright and white? Well, this is because snow is really good at reflecting the sun's energy. We can sort of think of it as like sunscreen for the Earth. When we have it around, it's reflecting lots of the sun's energy, and that energy goes back into space. So the reason it looks really bright to us is that all that energy and light that's coming from the sun is being reflected backwards. If you could press next, Joe. The word we use to describe this property of snow is called albedo. You can just think of this as a term describing how much energy can be reflected. If you can press next again, please. So we can say that snow has a very high albedo because it reflects lots and lots of the sun's energy. If you could press next, please. But when it's gone or it's not even there, the Earth's color is a bit darker. And because of that, it absorbs more energy and produces heat that we can feel. And we can say that this part, during this time, the albedo is lower because it's absorbing that energy. So if you've ever touched, say, an asphalt road on a hot sunny day, you might have felt this effect where dark surfaces can heat up really quickly in the sun. So thinking of snow as sunscreen for the Earth, we can see why it's an important part of understanding climate change. When it's there, it helps to keep the Earth cool because it's reflecting a lot of the sun's energy. Well, when it's not, the air can get warmer. Unfortunately, when this happens, it can melt more snow, making the problem even worse. So there's a cycle that occurs here. When we have less snow, it can get warmer. When it gets warmer, we can get less snow. If you could press next, Joe. We call this the snow albedo feedback. and this is part of climate change and one of the main things that I'm trying to study. If you could press next. And we know that snow is an important part of our climate, but it's also very important to animals in the Arctic. So my good friend here in the top right, the polar bear, likes to build its home in the snow, in building dens in the winter. It also uses it to get out onto sea ice to hunt for its food. The animals in the bottom right here are called muskox, and they live in the Arctic, and they need snow cover to protect their food in the winter so that they can dig down and still get to it after keeping it fresh for them. When snow changes, it can affect these animals, making it harder for them to survive. Next, please. Many humans rely on snow as a source of drinking water, so it's really important to us as well. Snow itself is just frozen water, so when it melts, it returns to liquid water, and then it can fill our lakes and rivers. Even in really warm places like, say, California, snow from the mountains is used for drinking when it melts. So it snows in the mountains where it's still cold, that snow melts, and it comes down to people in the valleys. Humans also have been using snow to get around for a long time. So on a snow machine where there's no roads, we sometimes can go on a snowmobile, like in the picture in the bottom right, or even in parts of Canada, we use snow and ice to build roads on lakes. Now we should remember again that just because we don't see snow around us, it's still part of our everyday lives in a lot of cases because it can give us water to drink, it can help power our homes, or influence our climate. Next slide, please. Now, we mentioned earlier that we can use satellites to measure snow and ice. Well, about 7 months ago, as an example, NASA launched a new satellite into space called ICESat-2. This satellite can be used to measure things like how much snow has fallen on a glacier or how much of that glacier has melted by sending a laser beam from space to the ground, which helps us to measure the change in distance. So as there's more and more or less and less, that distance will change. Now, orbiting around the Earth in space, we can collect a lot of information about snow and ice. So in the animation on the right here, you can see that satellite going around and around and around the Earth. It can collect the information a lot quicker than any of us could if we were to go out and try to do it ourselves. And by looking at these measurements over really long periods, we can better understand climate change and how it might be influencing humans as well. Next slide, please. Now, to help us figure out what kind of satellites we need or what those satellites might be measuring, we have to do something called field work, where we go to the Arctic and we do tests. A big part of my job is designing field experiments, deciding where and when we collect information about the snow. We often dig down deep in the snow, like in the diagram on the bottom here, and do all sorts of tests. Next slide, please. So a lot of those tools that we use are very special. They have to be designed to not only work hard, they have to be able to work in really cold environments, but they have to be able to work fast. Joe, if you can press once again, I think it'll start the next animation. Okay, maybe that one won't start, but the tools that we're using have been designed to work in really cold environments, and they let us work really fast so that we can keep ourselves warm as well. Two things that they help us to understand, or two things that we need to understand, satellites to measure the snow. Okay, next slide. Oh. Sometimes in the winter, if you look outdoors, the snow might look all the same to you, just white and everywhere. One of the instruments that I use a lot to understand snow is a microscope. So you can see me using one of them in the picture here. And if you can press next, Joe. When we do this and we look at snow under the microscope, we can start to see a lot of details that we can't see with just our eyes. Now, this might look a lot different, the picture here, of what you would draw a snowflake looking like. But when snow comes from the sky and sits on the ground, it changes a lot depending on the environment. So I will use tools like a microscope to help us understand how those changes are happening. and if they're part of climate change, and how we can use satellites to measure them. Next slide, please. Now, I'm not sure how many times I've already said it, but the Arctic can be really cold. So you see some pictures here of everybody working in the field. We have a lot of ice on our face. So when we sweat, that sweat just freezes to us because it's so cold. We have to be really careful when we're working in these conditions because we don't want to get too cold or sweat too much. So we have to be very smart about how we're working. And you can see one of my colleagues in the bottom left here kicking his feet, trying to keep them warm. Now the ice doesn't actually hurt us when it's on us, but it sure looks funny. Next slide, please. To keep warm, we have to dress really well. So there's a lot of different equipment that we wear, but it's kind of similar to the things that you would wear at home in terms of the materials for our extreme cold. But one of the most important things that we carry is a survival kit. So we have to be prepared to stay outside overnight, even if the weather is bad. So inside that bag that's on one of my colleagues here are things like food, a sleeping bag, and a heat source. All things that we would need to keep ourselves safe if we had to stay the night. Next slide, please. Now, when we're in the Arctic, we're often very far from cities or houses, so we don't have the usual places to stay that you might find at home. So we bring our house with us. The picture here is where I was staying this winter. So it's out in the tundra in Inuvik, north of Inuvik in the Northwest Territories. We each get our own tent. It's cold, it's not heated at night, but if we stay in our sleeping bags and we make sure that we're well fed before we go to bed, it's pretty comfortable. Some of these tents that we take out with us even have a stove to keep us warm and allow us to cook our food. With all that snow around, the best way for us to travel really long distances is usually on something called a snow machine or a skidoo. So we can ride over the snow with these very quickly and get us where we need to go. The picture that you're looking at here shows 3 of snow machines with some toboggans on the back. So we have a lot of that scientific equipment we have to carry with us. We can put it in those toboggans and pull it with us very quickly. When things are really far away, like in the North Pole, we sometimes have to use planes to get there. Now the plane that you're looking at here has special skis attached to it so that it could land on the snow. You can see in the animation, our pilots are bringing down the aircraft very slowly. We're actually going to land right on the ice. There's no runway here, so we have to work with very skilled people to land. And it's about to touch down, and we're down safe. So to get to these really far places, we sort of have to make our own methods. We have to find a place to land on our own because nothing's prepared for us. But it's really important for us to make these observations because people can't get to them very often, and we need to be able to understand them. Next slide, please. Sometimes when we're in the field, we get visitors. Now, when we're working, we have to make sure that we put our heads up and we look around often. The reason is we don't want any animals to sneak up on us. So in this picture here, you can see a polar bear. We were working in a building in the Arctic, and we looked up and we saw a polar bear. Now, these animals are curious, but we have to be careful to respect them. When we're there, we're working in their territory, and they're curious, but they can also be very dangerous. So in this situation, we were very quick to move away from the bear and make sure that we weren't in danger. We also get visitors like wolves. So you can see one of the wolves here that's actually howling at us. The thing around its neck is a GPS tracker. So another scientist is actually studying this wolf. But when we were out on the sea ice, this wolf came up to us to check us out. It brought 2 of its friends too. We weren't in any danger in this situation, but again, we have to be very careful to respect this wildlife because we are in its environment. So I hope you enjoyed our tour of the Arctic today. Here's a little picture of some of us flying out of camp a couple years ago. I really enjoy working in the Arctic and studying snow. And as part of that, at Environment and Climate Change Canada, we've recently written a report on not only how snow is part of climate change, but a number of different things. So you can check it out at the website we've listed here. And I'm happy to hear any questions you might have now about my field work, about why we study snow, or just hear about how snow is part of your life. Thanks.